Welcome everyone to the Fairblock EVM Integration Quick Start tutorial. My name is Hash Titan. Y'all can call me Hash, a DevRel contributing to the ecosystem. For today, we're going to be covering general EVM chain integration using precompiles. Basically, we're showcasing this integration furthermore with an Orbit chain, but it's like an emphasis that it can be done with any EVM in terms of like the precompile edition. And an example of a sealed bid auction is going to be shown to actually showcase like transactions with said precompiles in the updated EVM as we walk through the code. So with all that, let's jump into it. Today's tutorial will cover a primer on Fairblock and specifically how it works with EVM chains using the EVM FairyKit with precompiles, some context on the Arbitrum Orbit tutorial itself, and then we'll walk through the actual tutorial, covering details on the precompiles code, the Orbit chain contract setup, and testing the sealed bid auction locally using Docker. And finally, we'll outline next steps for folks to take and then wrap things up. Overall, the video should be around 30 minutes. I'll do my best and on. So before we get into it, right, it's best to understand Fairblock at a high level. Now, you can find other videos sharing Fairblock's overall vision, but for convenience sake, I'll touch on a few things for you. Fairblock leverages dynamic confidential computing. Okay, that sounds like a lot, but it's pretty straightforward. Um, with this functionality, confidential computing, there's different various MPC schemes, right, where you can get the decryption key for a specific encrypted transaction, or you can even work with um, confidential computing, where the encrypted details um, are actually like part of a computation before they're even decrypted. So you can have even more various layers or depths of confidentiality in your process. But all that to say is that all these different solutions in confidential computing basically unlocks a very vast sandbox of new applications to be made. Basically, imagine how right now with the transparency of the blockchain is there's a lot of power, but there also is a lot of limitations. And so if you can have varying levels of confidentiality, you could have prevention towards, like improper voting. You could actually have encrypted voting, for example. And with this, right, then you can start to see that there's another layer of trust essentially gained using something like Fairblock, and thus you can create something that we refer to as credible applications. And these credible applications essentially use confidentiality and in a reasonable manner, and thus you actually have like very capital efficient DeFi mechanisms, AI models, and productive applications. And these new applications, they can be hosted within Fairblock's own network, Fairyring, where they can leverage native dynamic computation within the network itself, or it could actually be the confidential computation and the ability to process encrypted transactions, et cetera, can be managed within a partnering network, whether it be an EVM or a Cosmos chain or whatever, just a different type of network. They can work with Fairyring in various different ways using a bespoke FairyKit module, if you will. And the coverage of new apps will like is spanning not only in DeFi, but also like gaming and other interesting application niches. So it's a very exciting time for Fairblock and its ecosystem. So and well as well to like kind of help illustrate it too, some app examples that today's like blockchain has limitations for without confidential computation include things such as proper voting, sealed bid auctions, and of course DeFi with MEV protection. And so for more information about like the vision and architecture, you can check out the docs. And the architecture video we'll be posting soon. But with that, let's start getting into like the actual architecture of Fairblock that applies as well to, of course, the EVMs, because it's a very important, right? Like, I don't know about y'all, but I love Zelda. You wouldn't walk into a dungeon within Zelda or any game without, a dungeon map. It just equals bad time. So with that, let's cover the architecture here for a second too. So as mentioned, we will be posting a more detailed Fairblock architecture video that goes over the intricacies of each of the steps in the UX as well as the components. But for now, in today's video, we're going to be covering just the high level components, as well as what I like to focus on is the kind of like two macro steps involved in the UX. So let's cover it quickly. Essentially, this architectural schematic showcases, to me, four main components for the overall structure. So the first one is the actual destination chain, or in this schematic, it's called the example chain. In the docs, we refer to it as the destination chain often. And essentially, this can be an EVM, L1, L2, L3, Cosmos chain, whatever type of network you are working with. And it's going to, depending on how your structure is set up, it could possibly, store the encrypted transactions in its mempool, or work with it in different ways. From there, the second component to highlight is the Fairyring network itself. So that's the Fairblock network, which is a Cosmos chain in itself, and of course has its own ecosystem of apps, but as well in terms of what we're referring to today, using threshold IBE or TIBE, it's going to be it's going to be communicating with the destination chain and pushing out master public keys as well as decryption keys respective to the respective conditions and encrypted transactions it's working with. And then the third component that you don't see in this schematic is the FairyPort. So FairyPort is a software that is created to actually communicate between the destination chain and the Fairyring. So it'll be transmitting, receiving, slash like looking for event emissions from the destination chain and transmitting the master public keys as well as decryption keys from Fairyring to the destination chain. And really it's a relayer. And so you can use different relayer software as well as needed. And then finally, it's again not shown in this schematic here in terms of labeling, but there's just the concept of Fairblock FairyKits. And so FairyKits are essentially bespoke modules that have bespoke package software that enables different chain types. Again, EVMs, Cosmos. EVMs can be with precompiles, or if using something like Arbitrum Stylus, can be then using Rust contracts deployed on the respective EVM. Essentially, FairyKit will cover the guts that are needed to actually integrate a specific chain type with Fairyring, depending on the design decisions of the developer working with it. And so with those four components, you then have the high-level architecture here. So that's a nice segue to the overall UX, because then I can walk through the overall schematic here. Essentially, with the UX, I like to think about it in two main like blobs or categories, essentially, or steps. So essentially, the first step is where the user will come in and submit an encrypted transaction. So in today's tutorial, we'll be covering sealed bid auctions, for example. So they'll come in with their bid amounts and the conditions to actually get it to be decrypted. So let's say it's a block height, they're okay with it being decrypted after a certain block height. And from there, and that block height is typically referring to the block height within the Fairyring network. But those are details that can be covered more later. Essentially, the user will submit the encrypted transaction, the respective conditions, and they'll do that all through like probably the application front end. So the destination or the application front end's UX. And from there, it's actually leveraging the Fairblock encryption SDK, which I forgot to mention, is basically like a component of the FairyKit for whatever chain you're working with. So in this case, we're talking about EVMs. And so essentially, the encryption SDK is used to use the master public key respective to the respective decryption conditions, because they're a pair in this situation. And then from there, it actually encrypts the transaction and submits it such that it's stored inside the mempool of the destination chain. From there, so that's the basically big macro step number one. You actually have you submit the transaction, you encrypt it, and then you store that encrypted transaction in the mempool. The big macro step number two is that once the certain conditions that we set before, so it's a certain block height, let's say, for example, is hit, the relayers are constantly listening to the destination chain for event emissions to trigger the requirements for decryption to actually occur. And so the relayers will say, oh, yeah, block height's hit. Let's go to the Farrier ring. From here, the threshold aspect is seen within different MPC schemes. And in this case, we're talking about TIBE. So basically, the validators will each construct a piece of the actual decryption key, and together they'll construct the decryption key instantaneously, essentially. And after a certain threshold amount is hit in terms of like how much of the decryption key they've constructed, the rest gets extrapolated. So thus threshold IBE or threshold MPC schemes. And from there, it's actually then sent along the relayer back to the destination chain and finally used for decryption. And then thus the transaction can be executed within the destination chain itself. So in a nutshell, you basically have the encrypted transaction is submitted by the user. Sorry, the transaction is submitted by the user with details for decryption conditions. And then from there, the public key is generated from Farrier ring and worked with the encryption SDK such that the transaction is actually encrypted all in one step. That encrypted transaction is stored in the mempool. From there, once conditions are hit, so block height or what have you, so it could be even prices or whatever for an asset, then basically the decryption key will be generated from Farrier ring, and Farrier ring will then send that decryption key back to the destination chain, and then the transaction can actually be decrypted and executed, and whatever application logic can be had with the decrypted kind of message. So in this case, we were talking about bids. So maybe the auction is actually over, and then you can actually see the bid amounts for the resultant winners, right? So that's in general the high level aspect of Fairblock architecture. With the high level architecture understood, it's important to touch on the specific layer of decryption and execution. As stated before, the dine-in method is where apps are hosted within the Fairyring network itself, thus receiving direct confidential computation capabilities and other benefits. Whereas when partner networks want to work with Fairyring, they then need to decide on which path to take within what we call right now the delivery bucket. Look, I'm just always hungry, so we're just thinking about food. But anyways, it's just a good metaphor we use. And the delivery bucket is more referring to like when like the means regarding working with Fairyring to process encrypted transactions for a partner network. So the two main options that arise for EVMs when it comes to the delivery bucket include the EVM FairyKit and co-processing. There's a reason why this is focused on decryption and execution. The former option has Fairyring take care of cryptographic computation, but the encrypted transaction execution happens natively within the partner destination chain. The encrypted message is decrypted within the native network, in this case using TIBE, where the decryption key is actually generated from Fairyring. So a lot of things are actually happening within the EVM or the destination chain, but the decryption keys are being sent as well as the master public key from the Fairyring to the respective layer. On the contrast or other hand, co-processing basically relies on Fairyring for the most part to carry out the cryptographic computation, and thus there needs to basically be no mods to the VM, no precompiles or anything to the destination chain, really. All it does is receive and like the end state from Fairyring itself. It's really up to the designers, though, working on the respective project for like the destination chain, etc., to choose the best integration path to take. But this is just like a nice high level overview to help illustrate these design decisions. Of course, as always, please reach out to the Fairblock team as they are happy to help with that selection process. And then one other note is along the lines of communication between the destination chain and Fairyring itself. So essentially with today's tutorial, it gives an example of using TIBE with Fairyring. And so there's the circulation of the master public key from Fairyring as well as the decryption key, and they're carried out using Fairyport. or if you're working with Cosmos or something like that, IBC, or other comms such as Axelar and other relayer options. So basically, there's another layer of like design decisions at that point as well. In today's tutorial, though, it should be noted, like we're covering the details associated to the EVM FairyKit using precompiles, and we won't really get into the details of the communication options between the destination chain and Fairyring as the precompiles and how to use them in a general like EVM modification are the main focus of today. And we're obviously going through a tutorial that showcases like it working in full. Ooh, okay. So we got one more slide before actually jumping into the quick start code. Touch some grass. I don't know. Get some ramen. Just take a break. It's good to digest these things in chunks. But if you're ready to go, let's do this. Okay, so FairyKit, as mentioned before, is like a general term for various integration modules. It's that basically depend on the integrating chain and the developer's like design choices. So for today, we're focusing on how the execution logic is changed using precompiled logic added in through the file contracts.go file. It is basically further tested with a local Docker container in this tutorial to showcase like a local instance of everything working where you have an EVM with all of the functional needs associated to using Fairyring in a different kind of application. So our application is like a sealed bid auction, but a different application in the sense of like a credible application, as mentioned before. And just as like a high level overview of like what you'll see within the tutorial is like you'll see that the decrypt function has like decryption key and ciphertext inputs. That is basically the main thing that's going to be added to a typical Nitro repo. So the repo that has the ins and outs of a typical EVM that we've just forked from Layer Labs. And the Fairblock libraries, distribute IBE, and others are actually added as well into the setup. And an important note is that the Orbit setup repo and the Nitros repo provided have already pre-registered Orbit contracts just for the sake of time. So they correspond to already pre-existing L3 Orbit chains that we will test with. These are just test chains. So we're actually going to be providing like an ENV with dummy wallets that are literally just having assets like ETH for the L3, not real ETH, just test ETH. It's not even, it's like a tertiary layer of test ETH, so you really can't do anything with it. It's just for the Orbit trade. So don't bother trying to steal funds in on. And yeah, and essentially that is hopefully going to make the process a lot quicker. Of course, if you want more of a detailed step through of everything, we have a detailed README walking through actually how to create an Orbit chain from scratch. But again, today's focus is more so showcasing like the pre-compiles code, what's within it, and then showing it actually working within within a local Docker instance, such that we can see like the modified EVM at work. And we're going to be using a sealed bid auction test example just to showcase this confidential computation with TIBE. All right, so now let's walk through some code. So here you'll see a fork of the Orbit setup script repo. There's two main repos within this tutorial, the Orbit setup script repo and the Nitro repo. So these forks are currently under my handle, but they will be moved to the Fairblock organization and live there and be managed there accordingly. So if we just quickly skim through the README, you'll see that there are two main parts of this tutorial. So the README that people will follow is going to be mainly, and it'll be copy pasted into the docs for quicker reference as well, if you're reading it from there. But essentially, like of course, like as always, I recommend having two screens or something set up so that you have the README on one side and then the code in another. So clone these repos onto your respective machine. But basically, there's two parts to this. So there's two big parts. One is where you're going to be deploying your own EVM with Fairblock precompiles into an Arbitrum Orbit chain, and that will communicate ultimately with the Arbitrum Sepolia test network, kind of like on the settlement layer. And this will result in an accessible Fairblock functionality at address 0x94 on the Orbit chain. So essentially, that's where the precompiles will live, and that's how they'll be accessed. So if you're writing a smart contract on the Orbit chain, right, let's call that the L3, then the L3 smart contracts would communicate with address 0x94. And all of that stuff is going to be hosted by a Docker container locally within this tutorial. So that's step one. And then step two is going to be deploying and testing a sealed bit auction smart contract written in Solidity, and it'll work with the precompiles logic from part one. So essentially, it's trying to give like a sense of how to actually integrate into the what is done in part one. So if you're an application smart contract developer and whatnot, and you simply just want to understand like, hey, I want to work with an EVM that has the precompiles. I don't care about how the precompiles are added in or whatever. I just want to work with them, integrate with them. Then I would just jump to part two of this tutorial. We'll add time stamps to this video accordingly. And of course, just scroll down in the README for it. Otherwise, if you're interested in actually modifying your own respective EVM, then focusing on like the precompiles, like what is added and why it's added, and modifying your EVM accordingly is the important aspect to focus on. And as for the repos, like so this repo, make sure to take the appropriate feature branch. It'll be in the README specified. Um, it's right here, just like the Fairblock demo Orbit chain. And like this repo is one of them, as well as the Nitro repo. Um, and essentially, the Nitro repo here, it'll have the precompiles within its code and be running a node within a local Docker container. Like that's where all the code is for the Docker container. And then the Orbit setup script repo is a fork from Arbitrum Orbit that has already pre-deployed chain contract configs within it, as mentioned before. Um, yeah, and basically these two repos, as mentioned before, were made for the sake of time for this quick start. So if you really want, as mentioned, like I wanted to point out where the detailed README was. If you wanted the detailed README, it's just right inside of the this fork of the Orbit setup script, and it'll go through all the more nitty-gritty details as if you're like starting from scratch and deploying your own Orbit chain. As well, we're going to come back to the detailed one because that's where actually all the precompiled details are. So we'll take a quick like glance at it, and I just wanted to touch on that too. Cool. And so yeah, overall, as mentioned before, I just wanted to really highlight that like the precompiled changes that we're going to implement, they are agnostic to like any EVM network, so Arbitrum, OP stack, etc. Um, just today, we're going to be focusing on using like the Arbitrum Orbit chain at like after we implement the precompiles into an EVM. Okay, so basically, as I mentioned, like the detailed README here more so actually showcases like the changes that are made within the respective like EVM setup. So here you can see um, we modify the contracts.go file within this fork of the so it's actually happening here. Like we take this fork of Nitro and essentially we're modifying the contracts.go. So if you're working on your own EVM, you would be modifying your contracts.go file. And essentially you're like we'll be adding more details after this video into the README, highlighting like the reasoning behind each of the respective like changes. But for now, all I will say is like, yes, we're adding in like the dependencies required. Like we're going to need the respective like IBE encryption, Kyber BLS for the like confidential computation like functionalities. And then as for like the actual like precompile codes and like the changes made there, like the big gotcha is that the decrypt function itself that we're adding in here ultimately ends up calling the library that we add in earlier, called like distributed IBE that has a decrypt function in itself as well. And once all these like just imagine basically, as I said, these repos like you're going to be like cloning the Nitro repo as well as the Orbit setup script repo onto your machine. But essentially, like the Nitro repo that you're cloning onto your machine already has these precompile modifications added to the contracts go file. All you're going to have to really do is like modify, is like make sure the dependencies are installed and move some files around accordingly, which we'll touch on in a sec. But yeah, essentially, after like these modified files, I'm just kind of like touching high level the steps were made. So it's like we went through, modified the precompiles, added the dependencies, and then lastly, like went into the vars for the precompiled contract of ours, and just found like precompiled contracts in Seoul, Berlin, and Cancun, and made sure we added in like the details for like where the address was for these precompiles. So that, as mentioned before, like 0x94 is going to be where the actual like decryption like functionality can be accessed when you're, say, like working on a smart contract, etc. Cool. So with those steps touched on, right? That's kind of like what's been done behind the scenes for your, again, for the sake of the time of the quick start. And like now, assuming you're just wanting to run through the quick start, essentially you'll have these two repos as mentioned before, and they'll already have the changes made to them. So essentially what you'll need to do, we have the, so I have my Docker running. I already have like the, it's I have the local instance running, and it's exposed at port 8449 on my machine. Um, so essentially, you'll have, as mentioned, like these two repos going. So the first step that you need to do within the Nitros repo is going to be actually do one. You'll need the node config JSON. So essentially, we have a quick start file here. So you want to copy and paste the node config.json file into the config file. So just right underneath config, you don't have to put it into these folders. Likely won't actually even be in your cloned repo. And then the other one is you'll want the contracts.go with the modified precompiles as mentioned before. And you'll want to put that in its also appropriate location. So it's under go with, like, once you install dependencies, you should see like a file, a directory called like go Ethereum, core, VM, and then you'll see contracts that go. So you'll have to replace that file with the appropriate one that we're giving you. And then from there, all you really have to do is run the command as seen in the README in the Orbit setup. So you're running this in the Nitro. So obviously install your dependencies, all that jazz. Run make Docker so that everything is actually syncing up. And then finally run Docker run. And then what that'll do is finally get you actually an instance running on your Docker container for the Nitros setup that you have. Now moving on, then you'll actually want to set up like the Orbit chain repo with the pre-deployed and initialized like Orbit contracts. So essentially, again, for sake of time, what we're doing is we provided the JSON files so that you can just set up everything in the config directory and then be off to the races and just be building everything accordingly. So we'll touch on that right away. Okay, so looking at our Orbit setup script repo that you have cloned onto your machine. Um, so basically, if you look at the directories here, you can see a couple main folders of interest. So one is the quick start. Inside, again, there are the JSON files that we've been referring to. Essentially, what you're going to do is copy and paste them into config itself. So I've already done that ahead of time. And then from there, we're also going to make sure the ENV is set up properly. So as mentioned, I wrote a big note here saying like, don't even bother taking the ETH. That'd be nice if you didn't. Cool. Because yeah, it's just test ETH. There's nothing in these wallets besides this fake Orbit chain or Orbit layer 3 chain setup, and some test ETH in there that is only literally usable for nothing else at the moment and probably forever. So anyways, yeah, so there's that EMB. You have EMB example. It's pretty straightforward. And then what we're looking at doing now is like working with these actual steel bid auction contracts. So feel free to dig into it yourself. These are not production ready at all. There's actually some commented out code on some aspects, but realistically, they still illustrate like the idea of pushing forward an encrypted bid. So a actual auction will run, and then users can submit encrypted bids. And it's basically leveraging the Fairyring technology and confidential computation functionalities. So you have like your submit encrypted bid, and then you have your reveal bids, and essentially all of that is carried out within this test script, which is furthermore called upon when running the sealed bid auction script. And so you see in the README, basically at this point, right now, let's refresh again, right? Like the Docker setup is maintained at the moment. And so we have the instance of our Orbit chain with the precompile modifications to the EVM there. made so that there is an actual precompile address exposed at address 0x94. Yeah, and then essentially you can see in the smart contract, right, like the precompile address is set to address 0x94, and then is interacted with accordingly within the smart contract. So if you're an app developer working with an EVM that has implemented the Fairblock precompiles in this similar fashion, then essentially all you'd have to do is interact with the 0x94 precompile, and from there just interact with it for your actual like encrypted transactions and processing them accordingly. And so if we go at the README, right, all we really have to do at this point is make sure we run the build script. So I've done that ahead of time already, so I won't do it right now. But essentially, you need to run this obviously to install the respective dependencies required. And you can see the build script here. Okay, so it's installing the submodules and then installing Rust, stylus. Oh, I guess we don't need stylus anymore in this one. From the previous project. We'll leave it in here but I'll clean it up in the actual setup. This is again just because the sealed bid auction example is a classic example that we've also used in our stylus integrations. But anyways, now if we just run the sealed bid script. There you go. So now you can see our contract is actually deployed, all again on the Docker instance that's happening right now. And then we can see that these encrypted bids are being submitted. You can see the actual like echoes and details within the script if you'd like to poke in a lot more. And then finally, if you just keep scrolling down, you can actually see, oh, look, highest bidder is 200 and the highest bidder is this address. And we can double check, like, is that accurate by simply going into the test script, again, within the actual like test folder. And we'll find 200 and let's put in a different number, put in like 180. And we'll look up bid value too. And essentially, there should be another one. Yeah, there is a bid value of 150. So 180 should be the new one if we run it again. Wait a second. Boom. So it's 180. So with all that done, basically you've seen me kind of like talk and discuss and showcase like two repos, and one repo being the Nitro repos that you can actually modify the precompiles on. And then from there have access to the functionalities offered with integrating with Fairyring and can process encrypted transactions using TIBE, at least showcased in this example and this tutorial. And from there, we showed how to actually deploy that in a local Docker instance using pre-made config files. For the detailed process of going through all that, you can look at our detailed README, which is again inside this is our fork of the Orbit setup script repo in README_detailed. So it goes through much more detailed at length compared to this more concise README for this quick start tutorial. Yeah, and then from there, we also covered like the actual use case of a smart contract that is interacting with the precompile address and at 0x94, that's just the standard address that we're using at the moment, and then from across other chains too, and test chains, I mean. And then from there, we actually ran a bash script that thus ran like interactive tests with a deployed contract on a local instance of the Orbit chain and local test environments set up, and saw that it actually worked in doing like an encrypted bid and then decrypted it and saw the end result of the auction, which was the highest bidder address as well as the highest bid itself. Yeah, so that's pretty much a wrap up of the code. All right, so we can see the power of Fairblock in action. So what's next? Well, you see now with Fairblock, safer apps can actually be built. There's already so much risk in crypto, so why risk it, man? Here are the next steps. For folks integrating, check out the docs and the Discord and reach out to the core contributors. For those who want to dig into things more, I mean, I'm not going to tell you how to to walk through a tutorial, but I do highly recommend checking out the detailed version, and jump around in this video, jump around in the README, the docs, and dissect the code where you need. And then from there, definitely you'll have more context so that you can kind of like troubleshoot on your own, and then reach out to us, of course, as you see fit and need more assistance. We're happy to help. And then lastly, if you're a community contributor, we're going to be opening up a repo for general integration issues, and for opportunities for people to help improve the processes. So please bear with us. It'll be coming out soon, and we'll share the link in the Discord. Cool. And with all that, thank you so much for watching. Hopefully, you've seen the power of Fairblock um, in in today's like blockchain applications and are excited to build with it. Feel free to reach out to me on Twitter or Discord at #Titan. And yeah, see you around. Get the heck outside. And honestly, man, touch some grass. Hug a real friend. Talk to you later.